Have you ever looked around and wondered, is this all there is? We experience the world in 3 spatial dimensions, length, width, and height, plus 1 dimension of time. But what if I told you that modern physics suggests there could be many, many more? Welcome to the mind-bending world of higher dimensions. It all starts with a simple idea. Imagine a creature that only lives on a flat, 2-dimensional surface. For this flatlander, our 3-dimensional world would be completely unimaginable. A sphere passing through their world would just look like a circle that mysteriously appears, grows, and then shrinks away to nothing. They can't perceive the 3rd dimension, but it's there, all around them. Could we be in a similar situation? This is where string theory enters the picture. It's one of the most promising candidates for a theory of everything, a single framework that could unite all the forces of nature, from the gravity that holds planets in orbit to the quantum forces that govern the subatomic world. And here's the crazy part. For string theory's math to work, it requires not 4, but 10 or even 11 dimensions of spacetime. So where are these extra dimensions? Why can't we see them or walk into them? The leading idea is that they are compactified. Imagine a tightrope walker from far away. The rope looks like a 1-dimensional line. But for a tiny ant on that rope, it has another dimension, the circumference it can walk around. String theory proposes that these extra dimensions are curled up, incredibly small, trillions of times smaller than an atom. They exist at every single point in our space, but they're just too tiny for us to perceive directly. These tiny, curled up dimensions aren't just a mathematical curiosity. According to string theory, the way they are folded and twisted determines the fundamental properties of our universe, the very fabric of reality, the masses of particles, the strengths of forces. All of it could be a result of the geometry of these hidden dimensions. It's like the universe has a complex, multi-dimensional origami structure that dictates all the laws of physics we observe. The fundamental building blocks in this theory aren't point-like particles, but tiny, 1-dimensional vibrating strings. Just like a violin string can vibrate at different frequencies to produce different musical notes, these fundamental strings vibrate in different patterns. Each vibrational pattern corresponds to a different particle. An electron is one note, a photon is another, a quark is yet another. So, the rich diversity of particles we see in the universe is just the cosmic symphony played on these tiny, vibrating strings. All matter, all energy, everything is just music. This theory also offers a potential explanation for one of physics' biggest mysteries, gravity. Why is gravity so much weaker than the other fundamental forces, like electromagnetism? String theory suggests that while most forces and particles are confined to our 4-dimensional brain of spacetime, the particle that carries gravity, the graviton, is not. It's a closed loop of string that can leak out into the higher dimensional space, the bulk. This leakage would dilute its strength, making it appear weak to us here on our brain, of course. This is all still theoretical. We haven't directly detected extra dimensions or tiny vibrating strings. Scientists at places like the Large Hadron Collider are smashing particles together at incredible speeds, hoping to find evidence. Like seeing energy disappear from a collision as it leaks into another dimension. It's a frontier. A science that pushes the limits of both our technology and our imagination. So, the next time you look up at the night sky, remember that the reality we perceive might just be a shadow of a much grander, higher dimensional cosmos. We might be living in a 10-dimensional universe. Our existence defined by the vibrations of infinitesimally small strings. It's a beautiful and humbling thought that reminds us there's always more to discover. Thanks for joining me on this journey through the dimensions. If you enjoyed this trip into the weird and wonderful, don't forget to like, subscribe, and hit that bell to stay curious with us. See you in the next one.